Hello, I'm going to go over the Geometry Semester 2 review for the final. This is Part B for you today. Find the sum of the interior angles of a decagon. You will note on your formula sheet that S sub n, the sum of the interior angles of any polygon, is the number of sides minus 2 times 180. So a decagon has sides of 10, so we put in 10 in the formula. 10 minus 2 times, need to subtract first, times 180. So we have 8 times 180, which is 1,440 degrees. We only want the sum, so we do not divide. On number 2, however, it says find the measure of each interior angle of a regular pentagon. A pentagon has 5 sides. We use the same formula. Now we're finding S of 5 for a 5-sided polygon. 5 minus 2 times 180. We got 3 times 180, which is 540 degrees. When we want to know what each interior angle is, it has to be, of course, a regular pentagon. To do that, we take 540 and divide by the number of angles, which is the same as the number of sides. So we do 540 divided by 5, which gives us 108 degrees for each interior angle. Find the measure of each interior angle of a regular octagon. Now we're just doing S sub 8, which would be 8 minus 2 times 180. That's 6 times 180. That's 1080. So the sum of the interior angles of a regular octagon is 1080. And we want to know the measure of each interior angle. So we need to divide by the number of angles, which again is equivalent to the number of sides. We divide by 8 and we get 135 degrees. Number 3, find the sum of the measures of the exterior angles of a nonagon. Doesn't matter. A nonagon has 9 sides, but that doesn't matter. The sum of the exterior angles, if you recall, for any polygon, I don't care how many sides it has, I'm just making one up. Remember how we extended the sides? And I discussed with you that shape as you keep going around that figure. What would it look like if you started to spin it on its center? And that would give you 360 degrees. The sum of the exterior angles of any polygon is 360 degrees. Multiple choice question. If the lengths of the sides of a triangle are 12, 12, and 16, how would that triangle be classified? Well, first of all, we notice that it has 2 congruent sides. So we know for sure it's isosceles. So that gives us A, B, or C and eliminates D and hopefully E. We have learned in the past, and this is not on the formula sheet, the Pythagorean theorem that says C squared, if C squared equals A squared plus B squared, C being the largest side and A and B being the other two, the smaller two, then it would be a right triangle. We also learned that if C squared was less than A squared plus B squared, then it was an acute triangle. And if C squared was greater than A squared plus B squared, then the triangle must have been obtuse. So in this case, the 2 smaller sides would be the A and the B. That'd be 12 and 12. And we're going to compare that to 16, which would be your C value, or C squared. 16 squared is 256, and that's going to be less than 144 plus 144, which is 288. Since 256 is less than 288, we know that this triangle is acute. We already established that it was isosceles, so it's an acute isosceles, and it would be choice A. Number 5. The area of any parallelogram is simply base times height. For whatever reason, students start to divide by 2, and I think it's because they see a triangle right here. I'm really not too sure why that's happening. However, we need to use our special right triangles pattern, excuse me, that we've discussed many times here. If we have a 30, 60, 90 special right triangle, the side across from the short leg is our reference side, which is N. And in relationship to that side, the hypotenuse is twice as big, so it was 2N. And the side across from the 60-degree angle, or the long leg, was the short leg, N, times the square root of 3. So if I look here, I see that I have the hypotenuse is 18, so I divide that by 2 to go backwards, because 2N equals 18, then n would be divide by 2 and get 9. So that means the side here would be 9 because it would be across from the 30-degree angle in that right triangle. That would indicate to us that the side across from the 60 would be 9 times the square root of 3 by following the pattern. Since we have now got the height, that's the height of our parallelogram. Now don't forget, the base down here, AD, is the same as BC, which are interchangeable as the base. This is 28. So our formula for the area is base times height. We'll do 28 times 9 square roots of 3. We'll need our calculator for that one. 28. Why that isn't already loaded. One moment. So I already had done that earlier. 28 times 9 square root of 3 is 436.5. And that would be in square centimeters because it's an area. We've been doing volume lately, and we've got to go back now and remember area is square units where volume is cubic. Don't forget, length is linear. Area of a trapezoid formula is on your formula sheet for the final. It says area of the base, area of a trapezoid is equal to 1/2 the height times the sum of the bases. If you would prefer, we went about it this way. We said, let's add our bases and divide that by 2 and then multiply by the height. So either formula can be used, whatever you prefer. The area for this one, since we have the bases are 16 and 28, we add 16 and 28. Don't forget that the order of operations matters here. We need to add before we divide. And the height here is your 12. 3 times 12. Our area then, 16 plus 28 is 344, and we divide that by 2. And then you can go ahead and type that in your calculator, but if you're going to type it all at once, don't forget you must have parentheses in there. This is actually 22 times 12. All right, and that would be 264, and we are again doing an area to 264. Those little slashes right there, that means feet. That'd be square feet. Okay, number 7, I say, well, it says find the area of the triangle. The area of a triangle formula you have on your sheet, base times height divided by 2. The base here is the 16, the height is the 7. The other information that's provided on the triangle would allow you to do the perimeter if you wanted to add up all the sides of 8, 11, and 16. Then you could get the perimeter. But we're being asked for the area. So we're just going to do 16 times 7 divided by 2. I can actually divide the 16 by 2 and get 8. 8 times 7 would be the same answer as if I multiplied those and then divide by 2, and that's 56. And I don't know the units, so square units. Number 8 says find the circumference of a circle with a radius of 7.5 kilometers. The circumference formula, you can use either the 2 pi times the r, that's going to be on your sheet, or pi times the or diameter times pi, or pi times the diameter is what it's going to say. I've used in class, I always kind of try to keep you separating the circumference formula from the area formula. So I constantly was telling you, if you are going to find the circumference, then let's find the diameter before we do anything else. 2 radii make a diameter, so we multiply 7.5 by 2 and gives us a diameter of 15. Then I can just type in my calculator pi times 15. If you choose to use the first formula, it would be 2 times pi times 7.5, and you'll still get the same answer. So I'll type pi times 15 because I like less to type. 47.1 to the nearest tenth. And that would be in kilometers because it's a length. Circumference is a linear measurement. Number 9, find the diameter of a circle. Now, since I want to find the diameter, I'm going to use the pi times the diameter formula. They gave me the circumference C to be 37.68, so I'm substituting that into the formula. We would need to get D alone, so we divide by pi. I'm going to use the calculator and the pi value on the calculator, 37.68 think that was, double check my, yes, divided by pi. I got 11.99. Since we've been doing to the nearest 10th, that's going to round us to 12. So that'd be 12 meters. Number 10, describe each angle as an angle of elevation or an angle of depression. Angle 1 is an angle of depression because it's opening from a horizontal. All angles of elevation or depression open from a horizontal and open downward. Angle 3 is also an angle of depression. It's opening down from a horizontal line. While angle 4 from the horizontal is opening up, so it's an angle of elevation. Ratio similarity of two figures is a comparison of their two sides in reduced form. The only pair of sides that has a pair of numbers on it that are corresponding is AB and RS, 5 to 15. We can write it as with a colon or as a fraction, so I don't care, but as long as you do this, you need to reduce properly. Divide by 5 top and bottom, that'd be 1 to 3. Or 1/3. Since the ratio of similarity is 1 to 3, we can use it to set up a proportion to find the missing parts. Or you can use just looking at the figure. I don't mind if my students say 5 is to 15 as 9 is to x, because they're coming from the first to the second, first to the second. Then we know by a cross products property that the cross products are equal. So we multiply 5 times x and 9 times 15, that'd be 135. My pen's stuck. And then divide by 5. So we would get divide that, let's see, what's that? 20, and I'm brains, 27. That's where x is. Okay, now if you chose to use your similarity ratio, the numbers wouldn't have been as difficult to deal with. We could have done 1 is to 3, first figure to second, as 9 is to x. And then we would have gotten that 27 really fast. So that's what I'm going to do on the next part. I'm going to find y. 5 is to 15, or 1 is to 3. I'm going to try to find st. 1 is to 3 as, see how 12 corresponds with the y. 12 over y. First figure to second, first figure to second. Y would then be 36. Get those nice and clean when we use the reduced ratio. Ratio of the perimeters is always the same as the ratio of similarity or ratio of the sides. So it's going to be 1 to 3 as well. But the area ratio, remember this was A to B, this was A to B, and we said that A to B for the sides, A squared to B squared for the areas. So that's going to be 1 squared to 3 squared, which will give me an answer of 1 to 9. Number 12, it says, if these cubes have sides of 3 and 5 feet, are they similar? The answer is yes, all cubes are similar. And I'll use a symbol for similar. What's the ratio of the sides? Well, it's 3 to 5. The areas would be, remember, this is your A to B. This is your A squared. Areas is A squared to B squared. So that's going to be 3 squared, 9. To 5 squared, 25. Volume, that's A cubed to B cubed. So for that, it's going to be 3 to the third to 5 to the third. 3 to the third is 27, and 5 to the third is 125. To find the length of the arc. Length of an arc is not the same as the measure of the arc. The measure of the arc AB is 60, and we use that in the formula, which says the arc measure, or x degrees out of 360, times the circumference of the circle, which is pi times the diameter. So I look over here and I see that the radius is 9, which means my diameter is 2 times 9, or 18. Then I find the arc length by doing 60 degrees, the measure of the central angle, divided by 360, times pi times the diameter 18. Now you could reduce this to 1/6, but and then you could work on getting it in terms of pi. It'd be 3 pi, but I'm going to go ahead and do it on the calculator because I tell my students to go the nearest tenth or hundredths. 60 out of 360 times pi times the diameter of 18. And I got 9.4, or 9.42 if you're going to the hundredths place. And that would be just in inches because it's length. It says the area now of the sector. Okay, so if that means we're going to find out what this piece of pie or this wedge's size is. This time we're going to be doing part of the area. So we do x degrees out of 360 times pi r squared. Area formula for a circle is pi r squared. So we do the same thing, put in that 60 for our arc measure, our angle, central angle. Oops. And now I'm going to put the radius in, which we already knew was 9. Okay. So I type in 60 divided by 360. Pi times 9 squared. Okay, and these are totally different units. This is 42.4. And if I want to go to the hundreds, 42.41. The inches are squared. These are square units now. We're looking at the space it covers instead of as opposed to the previous answer, which was just what's this length of this thing right there. Okay, number 14, find the values of x and y. First thing I would say is, hey, I got a parallelogram here. Opposite angles in that thing are congruent. So y is 82 degrees. Oh, it says find the values of x and y, then it says find z. Well, let's just find them all. So x degrees, I'll find out in a second. I already found y. So I'm going to have a blank for x, and I'm going to find y, which I just did. That's 82. Now, if angle y is 82, see, we can find z really fast because we got parallel lines, alternate interior angles are congruent. So let's use that property and get 58 degrees for z. All right, now let's find x by using the triangle angle sum theorem. Of course, that says that the sum of the three angles of any triangle is 180. We've gone over that one so many times. So we're going to use it again. So let's do 180 minus 82 minus 58. That'd be 98 minus 58. So it's going to be 40. Excuse me. The number 15, here we go. Find the value of x and y. Oh, these are supplementary. They're consecutive interior angles that are supplementary between these parallel lines. Also, we got an isosceles trapezoid here. So that x has got to be 133 degrees because the base angles in an isosceles trapezoid are always congruent. And since these are supplementary, we'll do 180 minus 133 in our calc and get, what is that, 47. Or angle y. Find the length of x if AB is a midsegment. The midsegment theorem tells me that if you add the bases and divide by 2, you will get the midsegment of 15. But we need to find one of the bases. So we're going to need to multiply by 2 now on both sides to eliminate that division of 2. And then we'll subtract 12 and get 18. Now, I taught it another way. I said, well, how far is it to go from 12 to 15? Well, that would be adding on 3. So let's just add, since this is a bigger one up here, let's add on 3 that way. And then 15 plus 3 is 18. So whatever way works for you. This is by the formula in the text. ADBC is a kite and AB is 22. This long diagonal in a kite bisects the short diagonal. So this would be 11 and this would be 11. So AX is 11. Given that BC is 14, BC is 14, right there. Find CX. So I'm going to find this, and I'll just call it A, whatever you want, little a. I know that the diagonals of a kite are perpendicular, so I'm going to use the Pythagorean theorem here, as we've done so many times. A squared plus 11 squared is 14 squared. A squared, let's see, 121 and 196. We need to subtract. 196 minus 121 would be 75. And then we'll take the square root and allow a decimal answer to the nearest tenth. So the square root of 75 is the answer to finding CX, which we will type that on our calculator. Reminder, hit your second button, the x squared for the square root symbol, put in the 75 and hit enter. 8.66 will round to the nearest tenth, 8.7. This pen is sticking. Number 18, the given figure is a parallelogram. AC would be, well, if that's 6, the diagonals of a parallelogram bisect each other, so these are equal. So that would mean AC is 12. Just add those two segments. ABCD is a kite, find the measure of angle C. The large angles, excuse me, these angles are congruent. We have two angles given. The sum of the four angles of any polygon is 4 minus 2 times 180. Sum of the interior angles. That's 2 times 180 or 360. You may have remembered the four-sided figures. Sum of its angles is 360. You can start subtracting those angles that you already have. These two are congruent. So once we find out that difference, we can divide it by 2. So I'll go 360 minus 142, oops, I typed that wrong, minus 25, I don't know if I think I might have remembered the numbers wrong. No, 193. Okay, so then I have to divide that by 2. Because I have to share it. So that would be, oops, I can just hit my answer divided by 2. All right, that's 96.5 degrees per angle. So the measure of angle C is 96.5 degrees. And as well as angle A would be the same. Number 20. We have an isosceles triangle. We know that the base angles of an isosceles triangle are equal. So you got an X right there. You could use the triangle angle sum theorem and say X plus 32 equals 180. Or you could say, well, that would give me the same result if I said, all right, I got 180 minus 32, and those two angles are equal, so I would just divide by 2 after I get, what's that, oh my gosh, 148. And then I would divide that. My writing is awful at the second. 148, I need to divide that by 2 to find each of those. All right, so they should be 74 apiece, regardless of how we approach it. This would give me the same result. 21, find the value of X and Y. Let's see. Oh, well, these slashes mean this is a rhombus. All four sides are congruent. So Y is clearly 16. This is 100 degrees, and since these are both equal, that means I have an isosceles triangle on either side here. It's cut into two isosceles triangles. So these angles right here, I've got 100 for that angle. So I go 180 minus 100. I know I've only got 80 degrees left to share among these two congruent angles. So they'd be 40 apiece. And these, the diagonal and a rhombus bisect angles, these are 40 as well. And that one's 100 because opposite angles are congruent. 22, ABCD is a rectangle and AC is 14. BD, diagonals in a rectangle are congruent. It would also be 14. And don't forget, they bisect each other. So all of these little segments could have been found too. They'd all be 7 apiece. Find the value of x by showing all work. We have a proportion and we know our cross products are equal. So we are going to multiply 7 times the x plus 3 equals 6 times the x plus 5. So distributing properly, 7x plus 21 equals 6x plus 30. Subtract 6x from both sides, giving you x plus 21 equals 30. Subtract 21 from both sides, and our answer is 9. 30 minus 21 is 9. 24, if you have parallel lines cut, or 2 transversals are cut by 3 parallel lines, then they are proportionally divided. So these pieces are proportional. So 3x is to 21, as 6 is to 18. Now this is reducible, so I'm going to do that so I don't have to go grab the calculator. And so is 6 over 18, that's 1/3. So 3x equals 7. X should come out to 7/3. A city is in the shape of a rectangle with a length of 20 miles by 15 miles. All right, 20 miles, 15 miles, not necessarily to scale. The population's 225,374 people. We're going to divide that by the area to get the population density. This would be 20 times, the area of this would be 20 times 15. That gives us 300. So I'm going to take the number of people and divide it by 300 square miles. These were a mile each. Grab my calculator. Oh, gee, I totally forgot what my numbers were. So let me go back to my picture. 125,374. And I'm dividing that by 300 square miles. So I've got 417.9 people per square mile. Oh, round to the nearest person. Well, imagine that. Doesn't that make sense? 418 people per square mile. 26, a football player. How many do I have left to do? Oh my goodness. Just checking. I'm tired. Almost 5:30 in the evening, and I just wanted to make sure I recorded this for my students in case they would like to look over these more carefully. A football player made 4 touchdowns in 6 games. Find the reduced ratio of touchdowns to games. Now pay attention, of course, to what order it says it. So if it says touchdowns to games, I need to go in that order. Sometimes we don't read carefully. 14 to 6, the reduced ratio would be 7 to 3. Or you can write it like as a colon. The scale of a map is 0.75 inches is worth 15 miles. On the map, the distance between 2 cities is 3.25 inches. We're going to use a proportion and put that 3.25 inches on top since our ratio is inches to miles. And we're going to figure out the actual distance between the 2 cities. Oh, we're going to cross multiply and divide. I'm going to do 15 times 3.25 divided by 0.75. All right, and I'll find those actual miles to be 65. Find the area of the composite figure. I see this is 10 right here, so I know that's 10, which is the base of that triangle. So what I'm going to do is make a plan and think about what this is. I've got a triangular shape to find the area of. Okay, and that triangle, we know the height, and the formula for area of the triangle is base times height divided by 2. We've been given the height is 8 and the base is 10. So we're going to do 10 times 8 divided by 2, which is 40. And then I'm going to think of the next shape I can see I find. That would be this rectangle. So I'm going to need to add on a rectangle that has dimensions of 10 and 24. The width area is easy, just 10 times 24, 240. All right, so you got that one. Now we've got half of a circle or a semicircle. Now we need to know what the radius of that is. Now we never think about it. Well, there's nothing marked on it, timer. Well, let's do it this way. Oopsie, I want to get a pen so I don't highlighter. If that's the center of that circle, then how far is it on either side here? If 10, well, this would be 5 and this would be 5. So we've got a radius of 5. So we're going to do the area of half a circle now. It's not the best half circle I ever drew, but it's pi r squared. Got the calligraphy pen on accident. I like that one, but kind of didn't do me justice here for this. Pi times 5 squared. The problem is I don't have a whole circle. That's the area of a whole circle. I have half of one, so I got to divide that by 2. Pi times 5 squared divided by 2. I have some music in the background. 39.3 for that piece. Now what am I going to do with all this? I need to put them together, right? So I'm going to get my total area. I got 40 for my triangle, plus 240 for my rectangle, plus 39.3 for my semicircle. So my total area equals 280, oh no, 319.3. I'll double check that on my calc. And I know that's in square meters. I need to slide my page down for you. Okay. So 40 plus 240 plus 39.3, if I remembered correctly. 319.3. Okay, number 29, this is a regular polygon. The area of the regular polygon is the apothem times the perimeter divided by 2, or half the apothem times the perimeter. The perimeter of this thing is 5 times 14.3, because all those sides, these are for regular polygons. All those sides add up to 5 different sides of 14.3. 50 was at 61.5. Okay, that's my perimeter. Now I'm ready to plug in the formula because this is your apothem right there, 8.2. So the area is going to be 8.2 times 61.5, if I did that right. 50. Yes. And then we're going to divide that by 2. I have a delay pen. All right, now I'm going to get my calculator. 8.2 times 61.5 divided by 2. Come here. Having some technology difficulties. 52.15 if it's the nearest tenth. I'm just going to leave it because it didn't say. I wouldn't mark off for rounding to the tenth. All right, 30. Write the component form of a vector given the start of the vectors at A, going through V, and ending at B. Component form is when you put the vectors as one. All right, let's see. It's on your formula sheet. Wanted to make sure that that was on there. Yes, it would be at the bottom left-hand portion of your formula sheet. It's component form. You take x2 minus x1, y2 minus y1. Now, your first point is the start of the vector. That's your, this would be excuse me. We're just going to sub x1, y1, x2, y2. Just making sure I don't have those backwards. But so we go -1 minus 6. And 4 minus -2. Much like we do when we do that distance formula. So our component form would be -7, 6. Find the magnitude of vector AB given the component form is -5, 8. Okay, so the magnitude, -5, 8. Now, if I drew you where that vector was, the magnitude is simply the square root of that -5 squared plus 8 squared. It's like the Pythagorean theorem. So if I drew this for you, left 5 and up 8, this is what it would look like. That would be the vector, and this would be -5, 8. So if I think about it like this, as a right triangle, that left 5 and this is 8, we would just do the Pythagorean theorem to find the magnitude. So you can just do 8 squared plus 5 squared basically, and then take the square root. This would be square root of 25 plus 64. So that's going to be the square root of 89, which is approximately 9.4. And 32, find the equation of a circle whose center is at 8. That's your HK. HK is the center of the circle with a radius of 7. The format for the equation of the circle is, oh my gosh, I just put a Y in the same, is x minus h quantity squared plus y minus k quantity squared, those are parentheses, equals r squared. And a lot of you have that down pretty well. We just have some trouble sometimes putting that radius in properly. The h is an 8, so we write x minus h quantity squared plus y. That's a -5 for k. Y minus a -5, we would end up with plus 5. And then you put in the radius of 7. You say r squared would be 7 squared, and 7 squared is 49. So that's one. Whoops. Okay, going haywire now. 33 wants us to graph the circle. Remember, it's x minus h quantity squared plus y minus k quantity squared equals r squared, that format. This time, we have a plus 3 here, so our h was opposite of 3. It's -3 for the h value. That's your hk. And y minus 4, that means the k was 4. The radius is r squared is 36, so we would do r equals the square root of 36, which is 6. So we plot the center, -3, 4, left 3 up 4. And then from there, we need to go 6 to the right, 1, 2, 3, 4, 5, 6. 6 to the left, 1, 2, 3, 4, 5, 6. 6 up, hear me, and 6 down, 1, 2, 3, 4, 5, 6. That's the only directions you can go. And then you just have to sketch a circle. Now we'll see if we can do a decent job. Mine's not great, but it's what we need. So we know how to plot, graph it. 34 says find the volume of the solid generated by rotating the sphere about the given axis. This is a rectangle. If I were to spin it around there, oops, I didn't do very good. Actually, they come more out like that. Spinning the bottom around. Oh. I'm going to get a cylinder. All right, that cylinder would have a height of 8 inches and a radius of 6. We are asked to find the volume. The volume of the cylinder is area of its base. This base area is a circle, so pi r squared times the height. So we're going to put in 6 for our radius, pi times 6 squared times the height of 8. Get the calculator. Pi times 6 squared times 8. So I get my volume, 904.8. cubic inches. I apologize if I've been going too fast, but I'm really doing this at the end of the after school hours, quite a bit after school hours, and I just really tired. You, of course, can pause the video and rewind or whatever you need to do so you are ready for your final exam. This will be the part B of the final, and of course, that will be occurring next week. And tomorrow we will be beginning part A. If students need extra time, we'll let them finish it on final exam day. Have a great evening. Bye.